This video will cover the topic finding intercepts of a nonlinear function given its graph.
What are intercepts, and how do we find them?
Intercepts are points that cross the x and y axis. Using this definition, we can find the intercept of our function on the graph by looking where the graph of our function crosses the x and y axis. Let's do problem 1 to see how we find these intercepts. Here we look to see if the graph of the function intercepts the x or y axis at any given point. Let's start with the x-axis. We can see that our graph crosses the x-axis at the points 1, 0, and 3, 0. This means that our x-intercepts are 1 and 3. If we look at our y-axis, we can see that our graph intercepts the y-axis at the point 0, 1. This means that our y-intercept is 1.
What would happen if the graph intercepted at the origin, or the point 0, 0?
In that case, we would say that the graph has both an x and a y-intercept at 0. If we look at problem 2, we can see that our graph crosses both the x and y-axis at the point 0, 0. As stated before, this means that we have an x and y-intercept at 0. The graph of our function also intercepts the x-axis at the point -4, 0, which means that our x-intercepts are -4 and 0. Since our graph only intercepts the y-axis at the point 0, 0, our y-intercept is 0.
Are there cases where the graph of the function might not have an x or y-intercept?
Well, let's look at these two graphs and see if we can answer that question. If we look at the graph on the left, we can see that the graph of the function only intersects the x-axis at the point 3, 0. This means that our x-intercept is 3, while we would put none for our y-intercept since the graph does not intercept the y-axis in the given information. The graph on the right intercepts the y-axis at the point 0, -2. This means that our y-intercept is -2, while we would write none for our x-intercept since our graph never crosses the x-axis.
One last question. What happens if we had a parabola where instead of crossing the axis, it only touches the axis?
That's a great question because our last problem involves working with the same issue. When we look at this graph, we can first see that our graph intersects the y-axis at 0, 1. This means our y-intercept is 1. As for the x-intercept, it is located at -1, 0, as the parabola is intersecting the x-axis at that point. This means that our x-intercept is -1.
So, in order to find the intercepts of a nonlinear function, we need to look at which points the graph of the function crosses the x and y axis. And we have to keep in mind that not every graph will have both an x or y intercept.